All right. Um, so we're going to look a little bit at data processing. There's this site called data.gov.sg. All right. Um, which is a place where the government makes available all sorts of data. And feel free to browse and explore. What we want to do is pick a data set and refine produce more refined data out of it. Generally, I tend to pick things that are rather neutral. So I'm going to do stuff related to population, stuff like that. Um, so build by site at a glance, view all data sets. All right. All right. So one. How is the data? How is the data available? Right. So you see these CSV files. Right. Maybe I have to click here. I'll just pick the first one. Right. Once you click on it, there is some sort of a rendition of this data immediately on the web page. Right. Looks like a table. I think in some cases you're gonna see some charts. Right. What we want, nevertheless, is we want to download the data. Right. And if we look at what we have downloaded, all right, there's a inside this zip file, right, which is automatically unzipped. There's a file that has a description, right? So there's a file called metadata, always. This is a typical way of presenting data by data scientists. And then there's a CSV file. So let's look at the metadata first. The metadata provides some sort of description, right? It tries to be some way structured, but there's no standard for it. All right. And one important thing is going to be the schema, which is telling you what are the columns available in this data, right? And the other one is a file called CSV, comma separated values. That's what CSV stands for, which typically is a text file. So it should be visible here, but it appears as if it's a formatted file. It is very easy to open with Excel if you have, all right? But if you don't, you can just open it with a run-of-the-mill text editor. Okay, the lines are very long, so I'm going to try to see where I can have all the lines on all the rows on one line, right? So the lines are wrapping around. This is one line, right? And that's the first line. This is the second line. So in each line, you see a set of words in quotes separated by comma. The commas are the reason for this being called comma separated values. It is essentially a table, right? Which is given row by row, and all the elements of a row are separated by commas. All right. The first row is the names of the columns and giving sort of an indication what they are. We can go to the metadata file, and for each column name, there is a little bit more of a description there, right? And it just goes row by row by row by row, which is easy to understand, makes it easy to understand why this would be a file that is easy to load into Excel. So I'm gonna put it in Excel as well. I know that Excel is in general not free, and then not everybody has access to it. There are equivalent applications. All right, and you can see it here in a table format and looks a little bit better. All right, so there's a so-called sequence number, which is I think in the wrong format, but it doesn't matter. There's an institution code, there's an institution name, and so on, right? So it's definitely a table. Now, we're not going to use this one. I'm just showing very quickly what is available and how you can access it. I am nevertheless going to use, and I'm just going to copy it from the previous semester because I always have trouble finding it on the site. But it's available somewhere on the site. I will use a file with a population profile. So going to here, so I'm going to go to what I used last semester, and I am going to have a similar file. I'm just going to make a copy. Oh, I can't make a copy. All right, but I know where it is available, so let's make a copy manually. So I'm gonna go back, look here, create a new folder, mkdir, week 6, Tuesday, and then copy Python 1 week 6, I think it was Monday. Oh, week 6 Monday, week 6 Tuesday. Last semester I had classes on Tuesday. So I'm gonna copy Singapore citizens by ethnic group and sex and June annual. I'm gonna copy it in the current folder, right? So now in the current folder I have this CSV file. All right, let's take a look at it. It's here, and I'm going to put it in a text editor because this has very short rows. Okay, so this is a breakdown on Singapore population. All right. No, it's not this one I want. Sorry. Let's copy the other one. Singapore citizens by age. All right, so we have one that is by age group, ethnic group, and sex, right? So I don't want to use this one because it will make the problem too simple to solve. So let me remove it. And let me put in the text editor. So this here the lines are a lot shorter, right? So what happens here? Starting with 1970, all right, we have a breakdown for population, right? So for every year, right, the level 1, level 2 is telling me what kind of breakdown this is, right? So we're looking at total citizens with age between 0 and 4 years, right? And this is the number of that population, of that segment of the population, right? If we look at this segment of the data, we have total citizen, right? Then the next segment of the data is total male citizen, followed by total female citizen, and so on and so forth, right? So this is the data presented to us, let's say. All right. Now, there's more segments. There's segments by ethnicity as well, right? So instead of going for male and female, we can go to total Malays, then total male Malays, total female Malays, and we keep going. And at some point, we're going to be done with 1970, all right? We have essentially, I think, 4 ethnic groups. We have Chinese, Malay, Indians, and other. And then we move to 1980, all right? Now, if we keep looking at the year, right, we see after 1980, it's 1990. And after 1990, we start to have data every year. So the data is not very consistent. And this is a very common situation in practice, right? Data is gathered by whatever means, and you don't have a lot of consistency to it, right? But from 1990, we have data every year. So we go to 1991, 1992, 1993, and we keep going till 2018. If I go and bring a fresh data set, I will probably get some 2019 data as well. So they typically, the data that they publish is about half a year old. So I might get data until, I actually don't think we would have 2019 data until the mid of 2020. So I think this is reasonably recent because it was downloaded in October or November, somewhere around there. Cool. So here's one thesis that we might want to prove. It's been said that that Singapore has an aging population. Can we prove from this data set that this is the case? Right? How would we do that? Well, for one thing, we're going to ignore 1970 and 1980 because they are outliers, right? We don't have data every year. But then the other thing that we would want to do is, starting from 1990, to compute the average age of the people in Singapore for that year, right? We have the segments. We have the segments and we have their numbers, right? 1990, we don't need to go by ethnicity. And obviously we can do analysis by ethnicity, but let's do it for total citizen first, right? So for every year, we select this segment that has total citizen. And for this one, let us compute the average age. Yes? And the average age is going to be, for this segment, I'm going to consider that the average age is 2.5 years because I have no other data. I can make no other assumptions. It might not be true, but that's all we have. And I'm going to take that age, or 2 years, not 2.5 years, 2 years, and then I'm going to multiply it by this. The average age here is probably 7. Multiply it with this, right? And then do a weighted average for all the ages and the population numbers for that segment, right? And this is how we find the average age. And then we can do that year by year, and then we can see how the age evolves from 1990 till 2018. These are the years for which we have data. Yeah. Okay. So we know exactly what we want to do. This will take about an hour to complete, so exactly what we need. All right. Now, I'm going to remind myself how to open a... Next time we're going to look at good times to buy cars based on our data set. So I'm going to remind myself how to open a CSV file, right? So Python is extremely versatile, right? And extremely well prepared for dealing with all sorts of situations. So this kind of CSV file is something that we can read very quickly. We don't have to parse this comma separation. We don't have to parse the lines of the text ourselves. We just invoke these read lines here, and then we get them parsed by the reader. We have a reader here, which is the CSV reader, and it's done. All right. So we're going to first read the file. I'm sorry that the font is so small. We're going to soon look at bigger fonts, and then that will sort out the problem. So this is our environment, which doesn't have any window open. All right, let me open a folder, which is here, 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 here. Actually, let's let's open this one. What are we opening now? Okay. All right, so here I'm going to open a new file. I'm going to call it data analysis.py. All right, later please. And going back here, right, from CFB import reader. So let's do exactly this. These are things that you can very easily Google. So if you go Python read CSV, you will get very clear instructions that will get you going very quickly, right? So with open, and we're learning a new instruction now. And we want the file title. So we can open this file, by the way. And I'm going to say copy. I think path is the best thing we can copy. And I'm going to put the file here. And, well, it's a bit long. So one thing I don't need to do is put the entire path. We can leave it there, it's not wrong. But since both our program and that file are in the same folder, it's fine. So with let me sure as F. Let me make sure I say everything correctly here. So unfortunately, I will have to bear with this very long line. There's nothing I can do about it. Well, there is maybe something. I can do something like oops. I think would be a good thing to actually turn off WhatsApp. All right, so I can have this name here, and then I can say CSV file name, and this makes this line a little bit smaller, shorter. How do I access files in general, right? There's a historic reason why we do it this way. In like 50 years ago, computers were very small. They didn't have a lot of memory. The amount of disk was a lot bigger than the amount of memory they had, right? Nowadays, it's still quite typical that you would have more disk than memory, but it's more or less, comparable. So you would have 16 gigs of memory and maybe 100 or 250 gigs of disk. But machines with 1 terabyte of memory in production in data centers are not that unusual, right? It's a lot more reasonable now to expect to just read an entire file into memory and process it, right? But back then, you could only process the file in pieces because you would have maybe, and I'm not kidding here, like 64K of memory was a very typical size. Not 64 megs, 64 kilobytes of memory, right? Which is something just the size of a, a movie is a few gigs, right, sometimes, and then imagine just 32K. And you would only be able to read the file in pieces, piece by piece by piece, right? So typically what you do is open a file, and then this operating system allocates some resources for processing that file. And then when you're done with the file, you have to close it, meaning that you have to relinquish those resources that were allocated for the continuous process of the file, processing of the file. So we open and close, right? Nowadays, because everything is so, and at that time you were so very resource aware, so if you didn't close the file, then there were these resources that were hogged and not available to other kind of processing. So you would always be careful about closing a file. Nowadays, we're not so careful about that, right? The problem is that if you don't close the file, actually there's a risk of losing data, again, for historical reasons. So an instruction like with will automatically close the file for us, right? So we want to process files inside a with statement. I am opening it, right? And I write some processing steps here, and as soon as I leave the with, right, this produces, this F is actually, it's the handle of an Opal file, but is generically known as a resource, and any resource needs to be relinquished, right? It has its own property of being relinquishable. So whenever I'm inside a with, all the resources that have been opened are automatically relinquished. And that's why we write it in this way. There are many kinds of statements that we would write. For instance, we can, let's say we access the database and we want exclusive access. We have a bunch of operations, 3-4 operations, but we don't want any interference, right? So we would use something called a lock. A lock is something that has to be locked and then unlocked, right? We often forget to unlock the lock. Coders often forget. If you put the lock inside the with, then it gets unlocked automatically. And I don't want to deal with this right now. All right, so we're going to, okay, if I agree, what happens? Can I just make it go away? Okay. All right, so I'm going to say that I'm going to produce an iterator out of f.readlines. So f.readlines is going to give me a sequence, but the sequence is lazy. We kind of discussed about this. It's an empty, it's a lazy sequence. It can be turned into a list. It can be turned into a tuple, but it would only be turned on demand when we specifically ask, right? So the file is still actually at this point on the disk, and then we want to turn all the lines via a reader, all right, into a list. So we're going to have, what do we call it? Records. Okay, records equals reader of IT, and then this is yet another lazy iterator. So we turn this explicitly into a list, all right, and it becomes a list. This is a list of all the records, and we're going to print this. Now remember that the first line in the list, actually for the time being, let's leave it this way, right? The first line in the list is the title of the columns, and then that's not useful data for us. But for the time being, let's just print the records and let's see what they are. So I'm going to print for I in range of 0 to 20. I'm gonna say print records I. All right, so this will give us an idea of what's there. We don't want to print all the 1,000+ lines in the file. We just want to print the first 20 lines. So data analysis, and here's what we have, right? So you see, we're printing record 0, then record 1. So this is record 0, record subscript 0, right? So we have produced a list but the elements of the list are lists. Yes, it's a list of lists. Every element of the big list is another list containing 4 values. The first one is the one containing the titles, and now I'm going to try to put them side by side. And let's go here, and notice that they are the same essentially, right? Can I? Okay, right? So notice year level 1, level 2 value. Here we have year level 1, level 2 value, right? It's a list of strings. Then the next line, again, a list of strings, 1970, total citizen, 0 to 4 years, and the number, but this number appears as a string. Yes? So Python is not smart enough to realize that the numbers are numbers, and it keeps them as strings, which means that we are going to have to convert. But all the lines, each line has been converted into an element of this records list. Right, so now we're in business. From this point on, we can start our processing. All right, so the first thing that we want to do is to filter the data. So one thing is to get rid of the first line. The first line is not useful data for us. Yeah. Then we want to filter the data so that we only have the lines with total citizen. All the other lines are not useful for us, yes? So if I go back here and I scroll up, at some point I'm going to have total female citizens, right? These are not so useful right now. Okay? So total citizen and total male citizen equally useless right now. Sorry, I started with the females. I should have started with the males being that would be the courteous thing to do, right? With the male being the male records being useless. All right, but nevertheless, right? So we keep the total citizens. Cool. So let's filter. How do we filter, right? So total citizen records is going to be, and I'm going to put a backslash here to make sure that the line is properly continued. So I am going to take every record R for R in records if R, and the second column is R1 equal to total citizen. All right. So the next thing that we want to do is say total citizen records here and make sure that the filtering was okay. All right, so we probably need to print a few more. So let's print 200 records. All right, so notice that as we browse through the data, all the records have total citizen in the second column. Yeah. Way to
load the file in Spider.
Why Spider is just an IDE, right? Why wouldn't you not be able to load the file?
So you just link it to the directory. At the start when it says CSV file equals.
Yes, so you see my Python file and the data file are in the same folder. All right, but if you don't have them in the same folder, you can take the entire path, right? So I can say copy path here, and I can, instead of doing just the relative path, I can do this. Yeah. All right. So it's the full path. And that will solve your problem. All right. So another thing that we want to sort out is the fact that the first groups are 1970 and 1980, which are useless for us, right? So I'm going to say if R1 equals total citizen and R0, which is the first column, right, is not equal to 1970 and R0 not equal 1980. All right. So if I do this, right, now I have even more useful data, right? I start on 1990. Okay. Now, what's next? One thing that is no longer useful for us is the second column, right? The second column is already the same, therefore it's not useful information. So we shouldn't keep it, right? So instead of saying R, taking the entire record, I should only take, right, as a list R0, R2, and R3. Okay? So now we're going to have only 3 columns. All right, the total citizen has disappeared. And we're saying some phrases that are would be very strange taken out of context, right? So imagine if somebody selects out of the recording this phrase, total citizen has disappeared. Could mean something completely different, right? So the total citizen column has disappeared. And we still have quite a bit of useless data, right? This data here is useless. Yeah. So whenever we have the word over in the second column, or actually in the third column, we should throw away that column, right? How do we know? How do we test if the last word is over? It's very simple, right? We select the last 4 elements of the string, right? So I'm going to put the if on the next line. Usually this is more elegant done in this way. So I'm gonna all right. So if R equal total citizen and R0 not equal to, right? And the next thing that we want is R3, which is the last column. And I want to take the last 4 elements, right? -4 onwards. All right, is not equal to over. So again, and it seems we haven't been successful. Minus. R2, yes, very good. All right, so we have selected even more data. Oh, and now it seems that we have very little data, that it all fits in in 200 lines, we actually reached 2001, right? So we fit quite a bit of data in 200 lines. So actually, I'm going to go here and just print, go back to 20. All right, so we have data that is now a lot more useful. All right, so what's next? The next thing is that I would like to replace the middle column with the average age. Yes, so you see this string 0 to 4 years, 5 to 9 years, 10 to 14 years, and so on, right? And I want to extract two numbers out of this string, all right? And I want to compute the average of that, yeah? So how do we do that? Well, the interesting thing is that we have fixed columns for all the numbers, right? So the first two columns are the lower end of the range, right? No matter what, the first two columns. Spaces don't count in general, right? Oh, why do I still have an over? Or I was looking at the wrong batch. It's strange that there's no, the last group is 80 to 84. I know there's actually many people in Singapore above 90 years old. So I wonder why they are excluded, but never mind. This is all the data we have. So we just assume the data is correct. But yeah, so that's why it is, right? The first two columns are the lower end of the range, and then the fifth and the sixth column in the string, within the string, right? I'm not talking about the table columns. I'm talking that if I take the contents of the second column, which is a string, the first two characters are always the lower end of the range, and the fifth and sixth are the upper end of the range, right? So the next thing that we want to compute is records with average age. And we're going to have a similar kind of problem. All right. So we want to have a list of the same three elements, right? But we have to decompose this list. So we're going to keep R0. And R1 is going to be replaced by the average. And I'm going to have R2 here, right? Now, this list, because this expression is going to be very long, this list is going to be spread into separate lines as well. All right? And now, right, R1, so if I take from 0 to 2, this means the first two characters, yes? And I convert this into an int, I get the lower end of the range plus, then the same R1, if I select the, let's make sure it's the fifth and the sixth. So 1, 2, 3, 4, 5, which if I start from 0, this is 4, so this is 5. 5 to 7 should be here. So 5 to 7. And then I divide by 2. All right, 4 are in total citizen records. Yes, is this clear? So I'm taking the R, I'm keeping the first column the same, I'm keeping the Last column the same. The middle column, I extract the numeric parts of the string, convert them into actual numbers because of this int, and then compute their average. Is this clear? So we want to print this guy now. And it seems we have. And we do need brackets. Yes, very, very good. I was wondering why it should always be an integer. I mean 0.0. I was wondering why the 0.5, and yeah, very good catch. So these are the averages, right? So the average age. So we have 219,067 people with the average age of 2, right? And so on and so forth. Cool. What's next? So next, we want to group together by year. We want to group these records, right? So I would like to group these records, set them aside from the records of 1991. Yeah. So this is a bit more involved, right? I can't do it just as a simple list operation. We have to build a dictionary. Yes. So we're going to start with records by year. All right, and this records by year is an empty dictionary initially, and then we're going to have for record in records with average age. All right, so I'm going to apply a trick here. So let me teach you the trick. Right, so normally if I have a dictionary, empty dictionary, if I try to extract anything out of it, let's say the value for key A, I will get an error if the key is not already there, right? But I can create a dictionary with a default value. Let me put in a bracket, maybe it's easier. I think it's with default. With the easiest thing to do is dir and then set default. All right, so I can say d equals this, then d dot set default 0. And then if I say d a, help d dot set default. Oh, I also have to this is not quite what I want. All right, let's not apply the trick then. It will take probably too long for me to figure it out. This is a dictionary where every key points into a list, right? So going back here, all these records will be corresponding to the key 1990, and then all these records and onwards will correspond to key 1991, right? And once I have set the key, I also don't need this column anymore, right? So I will not remove it first. We'll look at data, but then we also want to remove the first column. So for R in records with average age, so what are the situations, right? It may be the case that that records by year, the dictionary contains R0, right? R0 is my key, is the year, right? So what I would like to have is that records by year as a dictionary, so records by year, right, with the key R0, right, which is a list, will be records by year R0 plus R. Yes. Now the problem is that this thing might be none. Yeah. So if this is none, we actually have to check. What do we do if this is none, right? So I'm going to take it aside, and I will say value is this, and this value may be none, right? So here I'm going to say if val is none, then empty list, else val, right? So if this doesn't have a record for the year R0, then we're going to start with the empty list. Otherwise, we'll use whatever is there, and we'll plus R else val, and it should work this way. I'm wondering why. Sorry, not if. Empty list if val is none, else val. Sorry, this is how it works. Empty list if val is none, else val. All right. So then we are accumulating the records in the right key. So let's see what we get. So for I in range, so now we can no longer use this because we have a dictionary to print out, right? So we're going to have for key and value in records by year, right? We're going to say print key, and then we're going to print a few spaces and the value, and let's see what we're getting, right? So we're printing the key, and then on the next line, a bit indented, the value, which should be a list. Yeah, and the list will be quite big, so it will wrap around, so it will be a bit messy. So because it's going to be a bit messy, let's do another print so that we have a line of separation. And it's not what I wanted. All right. Line 26, key error. Records by year, sorry, I'm gonna say dot get. I think I explained the difference between get and the square brackets. Let's go here again. So let's say I have a dictionary which is empty initially, and then if I try to access a key that doesn't exist, I'm going to get an error. But if I try to access a key via get that doesn't exist, I'm going to get none. The fact that nothing is printed means that there's none, right? I can set a value there. So now when I try to retrieve D, I will get ABC. And if I try to get, I will also get ABC, right? So it's an important difference, because if I try to access, you just witnessed an error, right? That's because I forgot about this, right? An error will actually terminate your program, whereas with a none, I can still test and check whether the value exists, and if it is none, I actually can recover, right? I can say, oh yeah, use the empty list instead. So this will work. Too many values to unpack. Oh, this doesn't work like this. All right, key in records by year, and we're gonna have records by year K. This should work. And here's all our data, yeah? Not good, not good, not good, not good, not good. All right, so what is not good about it? It's that all the data is in one list. We wanted a list of lists, right? So we see that this is followed immediately by this. There's no structuring. Yeah. So in order to create that structuring that we want, but by and large is close to what we want, right? We want the key 1990 and all the data for 1990 here, right? And we want the key for 1991 and all the data for 1991 here, right? So in order to create the structuring that we need, I'm going to put a list around R. Yeah. So because of that, now our data looks like this, which is what we want. And we're printing a bit too much, but that's fine, right? So you see the data for 1990 is this. And this is the group whose average age is 2. This is the group whose average age is 7. Yes? And so on and so forth. The number 1990 right here is not useful anymore, right? Because inside this data set, inside this segment, it appears in the first column everywhere. If the first column contains the same thing, that column is not useful. All right? So we're going to get rid of it.
So
All right? Yes?
the key is 1990 and the value are the list.
The value is this. No. It's a list of lists. The value is all the records for that, right? So now I'm going to go year by year. I'm going to go year by year and then compute the average age. Okay? There's more things that we can do. The value that we are getting here, R0, is actually a string. We would prefer it to be a number. It's easier, right? So I'm going to say year equals int R0, and I'm going to say year, and I'm going to say year here. All right. Then inside here, I don't want R0, R1, R2, right? This entire R has 3 columns, has 3 elements, right? I don't want the first column anymore. So I'm going to keep R1 and R2, right? Which is the average age and the number of people in that group. All right. Now, the average age is also a string. We don't want it to be a string. We want it to be an int. Oh yes, no, it is a number, but this one it is not a number. So let's make it into a number. Okay. And then guess what? We need another list around. Yeah, is that clear? Why we need another list around? Okay, let's go slowly here. So we had this. Now R is a list with 3 elements, right? So R, which is a list, is equivalent to writing R0, R1, R2, right? So I'm going to say that R is the same as this. Is this clear? So then I'm going to take this and replace R. Replace R, right? So I'm going to replace this guy with this. And notice now already that you have 2 levels of list, yeah? Now, we just argued that we don't want R0. And we also argued that we want this to be an integer. So I can get rid of this. And I think here I need a bracket inside. Okay. Now let's be a bit more clever about printing so that it's a bit more clear. So I'm going to say for group in records by year K, right? And I'm going to print records. I'm going to print G, right? So then all the records are going to be printed on a separate line, and this is going to be a nicer print out. Okay, so I have to go a bit, not quite sure why that is selected. Right, so for 1990, the group of 2-year-olds has this many people, the group of 7-year-olds has this many people, and the group of 12-year-olds has this many people, and so on and so forth, right? 1991, same thing. Yeah, and so on and so forth. So now what I want to do is, instead of having so many records for 1990, I just want the average age. Yeah. So I'm just going to call it average age per year, average age each year. And this is also a dictionary that is initially empty. All right, and then we're going to say for K in records by year. And then whenever I put in a for loop, this is a dictionary, right? Whenever I do it like this, K will iterate over the keys only, right? So the dictionary has keys and values, but the iteration will be only over the keys. So what we're going to do now is records by year is a list. Yeah, records by year K is a list. All right. So we have to compute an average, right? So the average will be, well, let's call it total age, which starts at 0, right? So we're going to have a total age, and we're going to have a population, which also starts at 0, right? And then for each group in records by year K, right, we're going to have that the total age equals G0, sorry, plus equals G0 times G1, right? So G0 is the average age for that group, and G1 is the population of that group, right? So the total age of the entire population is going to be, right, because we're trying to compute a weighted average, and the population will increase by G1, right? G1 is only population. And then the average age is total age divided by population. And then average age this year, each year, for key K is going to be equal to average age. Yes? So finally, we can print out. So I'm not going to delete this, I'm going to just comment it out. And we're going to print. Actually, we can print directly. So we'll just print average age each year. This is good enough. And if I do this, it's not very nice. Okay, let's print it fully. Let's print it in full. So for K in average age each year, we're going to print K and average age each year K. Okay, so now we have, the proof. So you can see that in 1990, the average age of the entire population was about 30, and it ends in 2018 being about 39, right? Which is clear proof that, in general, the population is aging, right? The increase is quite steady. There's no years of decrease. So this is how we do it. Yeah, this is a very typical process of data analysis. So typically, you go on your exploration, whatever kind of analysis you want to do, you'd go and collect your data. The data will be sort of not clean. That's what data scientists call it. It's not clean data, right? So in this process here, we have cleaned up the data. We have ended up with data that has a certain regularity, right? And it's ready for refinement. That means that, yeah, we have a number of years, so that we have ages, we have data for every age group, right? We have eliminated those groups that are not very useful. We have eliminated groups that are not of interest, right? And we are ready to process. Then we start munging, right? So what follows is data munging. We are massaging data to fit different formats, right? So we take a string and extract numeric data from it, right? We group data to suit our purposes, right? And when we get there, we are actually ready to perform the actual computation, which is what happens here, right? For every group, we can compute the average age and that's the refinement that we were after. Okay. Now, obviously, you can produce different analysis. If you don't want total citizen, you can say total male here, right? And this will give you the analysis for males. Total male, what was it? Total male citizens. It's interesting because they say total citizen, but then total male citizens. So they prefer the plural when it comes to male. So if I say this, then I'm going to get data for the males. And you can see, interestingly, that males are a little bit, generally, if you put males and females side by side, males are a little bit younger. Right? So you see that in 2018, but consistently, if you put them side by side, males are a bit younger. It's a phenomenon hard to explain. We can do this for all ethnicities and so on, right? So it's very good to think about, if you want to make it generic, if you want at some point to change, to shift the focus, how easy it is, right? And what you want to avoid in such cases is having to change all over the code, right? So now, in order to change my focus, I only have to change it in one place, right? If I'm looking at ethnicities or gender. This is still not good because I have to go inside a code somewhere, right? Typically, my code will be a few thousand lines, and if I have to know that I have to go to line 623 to make a change, that's not very good, right? So one good thing, or if I need to change the file that I want to analyze, and this is in line 744, again, it's a bit difficult to change, right? So one good thing would be to say group of interest right at the top of the file, and say total citizen, and then come here with group of interest. So now I would know that, oh, well, this is the group of interest. If I change the string here, I'll probably get an analysis for a different group of interest. And this is today's class. Any questions? So one nice thing would be to plot a graph. The thing is, nowadays, what you should do is actually output this into comma-separated values, load it into a tool like Excel, and Excel will give you a graph. Okay. There are plenty of tools that are drawing graphs on the web where you can upload a comma-separated values file and get a graph out of it. So I don't see representing data and drawing graphs and pie charts and bar charts as a major skill in Python anymore, right? There are packages for that. But in general, it's more important to produce the data. Printing it or graphing it is not so much of a problem. Cool. If there are no questions, see you tomorrow. If you want to stick around and ask individually, feel free to.